morning, everyone. I'm Hao Sutang from School of Geography and Planning, University of Sheffield. Today, I would like to share with you the story of Antarctica and Antarctic sea ice. Within the next 20 minutes, we will explore how climate change is reshaping the polar regions of our planet and why it matters to all of us. The past April 2025 is the second warmest April on record. This figure shows the global surface air temperature anomalies for April, and we can, from this figure, we can see that the April 2025 is the second highest temperature on record. Even more striking is that April 2025 is the 21st month in the last 22 months for which the global average surface air temperature was more than 1.5 degrees Celsius above the pre-industrial level. The global warming is not only happening in the atmosphere, it is also happening in the ocean. This figure shows the ocean heat content evolution from the past to the future. And the future is projected by the climate models. And from this picture, we can see that from 1971 to 2010, the global upper 2,000 meters of the ocean are warmer consistently. Besides, ocean warming significantly accelerated after the 1990s with a high rate. It's like a pot over the stove. When we turn the heat, and the water thaws faster. In 2024, ocean heat content reached a new observational record, and about 90% of the excess energy trapped by the greenhouse gas enters into the ocean. Accompanying the warmer ocean is rising global sea levels. And the upper figure shows the time evolution of global sea level, and the lower figure shows a special pattern of changes in global sea level. And we can see that the global sea level are rising under climate change. And in the first decade of the 20th century, the sea level rise at a rate of 1.4 millimeters per year. But under the first decade of 21st century, the sea level rise at a rate of 3.6 millimeters per year. And today, the rapid melting of glaciers and ice sheets have become a larger contributor to sea level rise than the ocean thermal expansion. There's no doubt that the global is warming, and from the observations and climate model all forcing simulations, we can see that the global temperature is rising in the past century. But what is the science behind the global warming? The Intergovernmental Panel on Climate Change is a world-leading scientific body for investigating climate change. It is established by the United Nations during the last century to provide policymakers with scientific assessments on climate change. And in 2021, the IPCC launched its sixth assessment report, including over 20 authors from 66 countries. The main conclusion from this report is that anthropogenic greenhouse gas emissions is the main driver of the current climate change. And this figure shows changes in the global surface temperatures. And the left figure shows the temperature evolution over the last 2,000 years. And we can see that the current global warming is unprecedented, even in more than 2,000 years history. And the right figure shows the temperature evolution over the past 150 years. And the black lines shows the observations, and the brown lines shows model simulations with human influence, and the green lines shows model simulations without human influence. And we can see that only when we add the human influence in the climate model simulations can we simulate the rising temperatures in recent decades. That we can conclude that human activities have increased the greenhouse gas concentrations causing warming of the atmosphere, ocean, and land. And how is increasing CO2 contribute to the current global warming? This is mainly due to the greenhouse effect. Naturally, greenhouse gas like CO2 can trap heat in the atmosphere, thereby keeping our Earth warm. And we can see from this figure that the sunlight passes through the atmosphere, and the Earth can reflect the heat, which is absorbed by the greenhouse gases like CO2. And without this greenhouse effect, Earth would be about 30 degrees colder. And because of this greenhouse effect, human activities can intensify this effect by increasing the greenhouse gas concentrations. Now let's zoom in on the Arctic. This figure shows the temperature changes over the past several decades in Arctica, and we can see the Arctic is warming significantly. It's about twice or 4 times faster than the global average. And Arctic warming is disrupting local ecosystems, threatening species like polar bears and seals. It also has other implications. For example, it can alter the food webs and can affect other phenomena. The Arctic warming is much faster than other parts of the planet, and we can see from this from the left figure, the upper left figure, and the steeper line is the Arctic warming rate, and the other line is the global mean warming rate, and we can see the Arctic warming rate is much steeper than the global average warming rate. And this phenomenon is called the Antarctic amplification, and multiple factors can contribute to the Arctic amplification, including the sea ice losses, which can induce surface albedo and enhancing warming. Besides, a stable polar vertical temperature profile can limit outgoing long wave radiation, thereby warming the Arctic. Besides, increasing cloud water content can lead to stronger downward long wave radiation, thereby warm the Arctic. Furthermore, enhanced polarward energy transport from lower latitudes can also warm the Arctic, thereby causing the Arctic amplification. This figure shows the historical changes and the future projections of Arctic sea ice extent, and we can see that Arctic summer sea ice extent is shrinking rapidly, about 30% per decade, and ice-free summers may occur before 2050. Note that this ice-free does not mean Arctic with not sea ice. It just refers to the Arctic sea ice content drops below 1 million square kilometers, leaving tiny regions with sea ice near its coast. The Arctic sea ice changes can severely affect our lives. The left figure shows the conditions with strong westerly jet. It can constrain cold air in the Arctic. The right figure shows weaker westerly jet. In this condition, the Arctic cold air can move southward, thereby influencing our living regions. And under global warming, Arctic sea ice losses can weaken the temperature gradient between the Arctic and the mid-latitudes. This can lead to a weaker, more swift westerly jet stream, increasing the weather variability and weather and climate extremes in UK and US and other mid-latitude regions. Apart from the challenges, the shrinking Arctic sea ice can also bring new opportunities. For example, sea ice retreat may facilitate the exploitation of rich oil and gas resources in the Arctic. Besides, the opening of Arctic shipping routes through the Arctic Ocean could bring new economic opportunities. For example, the left figure shows a traditional shipping road and Arctic Northeast Passage under ice-free summers in the future. Compared to the traditional shipping road, the new Arctic Northwest Passage can shorten the distance from Asia and Europe significantly. Specifically, this distance can be shortened by about 7,200 kilometers, and the transit time can be significantly reduced, about 2 weeks. The right figure shows the ship count by the Arctic, and we can see during the past decade, the ship count in the Arctic has significantly increased due to its shrinking Arctic sea ice. And we all know Arctic sea ice is decreasing, but what about the Antarctica? First, let's give a Antarctica overview. The Antarctica is the southernmost continent in our planet, with vast ice sheets. It is the coldest place in our planet, and it is strong. It is surrounded by the three oceans. That is the Pacific Ocean, Indian Ocean, and the Atlantic Ocean. Although inhabited by person all year round, the Antarctica is home to a lot of wildlife like penguins, and it is also a hub for scientific research. This figure shows surface temperature changes over the past several decades, and we can see that the regions with the most red color is the Antarctica Peninsula. The surface temperature in the Antarctic Peninsula rose by nearly 3 degrees Celsius from the 1950s to early 2000s. It is nearly 5 times the global mean warming rate, and the West Antarctica, that is this region, shows significant warming, especially near the Amundsen Sea and the Beringhausen Seas. And the East Antarctica, that is this huge region, it remains more stable with weaker or no clear warming trends overall. This figure shows the sea ice extent evolution during the past several decades, and this one is for the Arctica, and this blue one is for the Antarctica, and we can see a significant contrast between Arctic and the Antarctica sea ice. Different from the shrinking Arctic sea ice, the Antarctica sea ice shows a slight increasing trend from the 1979 to the 2014, and followed by a significant sharp decline. And then this figure shows the spatial distribution of sea ice changes. And the blue color shows sea ice increase, and the red color shows sea ice decrease. And we can see that the sea ice trends were significantly over the Antarctica region. It increased over the Ross Sea. It is here, but with strong declines in the Amundsen Beringhausen Sea. This figure shows the Arctic ice sheet changes during the past 3 decades, and we can see that the Arctic has rose huge amounts of ice over the last 3 decades, contributing to around 7.6 millimeters to the global sea level. And the West Antarctica, that is this line, ice sheet is a primary contributor to the sea level rise from the Antarctica, while the East Antarctica, that is this yellow one, East Antarctic sheet is historically more stable, but the recent data also shows that some mass in East Antarctica in its coast region has been losing its weight. We have previously stated that unlike Antarctica, Antarctica sea ice slightly increased from 1979 to 2014, despite global warming. This is very confusing. Why could this happen despite so strong global warming? And it turns out that the remote tropical patterns can influence the Antarctica winds and pressure systems thereby inducing its phenomenon. Specifically, the climate patterns in the tropical can trigger the atmospheric tender collection pattern over the Antarctic region. We can see from this figure. This figure shows the Antarctic region, and this one is the Antarctic Peninsula. This is West Antarctica, and this is East Antarctica. The tropical climate modes can trigger low level pressure anomalies over the West Antarctica, and it can bring warmer air from Argentina to the Antarctic Peninsula, thereby warming the surface air temperature. On the other hand, this wind can blow the cold air from the Arctic to its surrounding regions, thereby increasing the sea ice over there because it's cold air. It can increase sea ice formation. In recent years, and the situation changed, and we can see in 2023, Arctic sea ice dropped to its lowest levels since 1979, and this is mainly because of the human-induced global warming. As a result, the penguins' colonies have suffered mass breeding failures due to premature sea ice breakup, threatening their survival. And during last year, East Antarctica has struck by a strong winter heat wave. During July 2024 to August 9, the East Antarctica, that is this region, has rising temperatures of about 20 degrees Celsius. That is a very strong temperature increase. And our latest research shows that anthropogenic global warming has significantly contributed to this unprecedented heat wave. And then this figure shows the probabilistic distribution of surface temperature in the East Antarctica. And the red line is with human influence, and the blue line is without human influence. And we can see, compared to the blue line, the red line shifts more towards the high temperatures. And this is high temperatures, and this is low temperatures. And we can see a warming shift if we add the human influence into climate models. And that indicates that anthropogenic forcing has significantly increased the probability of the 2024 East Antarctic winter heat wave, and increase the magnitude of it. So that is our the last part is our conclusion. First, human-induced greenhouse gas emissions are hitting our planet. Second, Arctic sea ice is shrinking rapidly, losing about 13% per decade, and ice-free summers are likely to occur before 2050. And Antarctic sea ice defied global warming trends for decades, but has now started to decline again. And the 2023 said it will cause loss. And the reports are warning lights of our changing climate, and what happens there can affect our whole planet. Yeah, and that is all my presentation. Thank you very much for your time and interest. I welcome any feedback.